So can we start with the class now? Okay, in the last class, you have learned how to solve a homogeneous second order differential equation with constant coefficient. Okay, so today we will look at the non-homogeneous equation, meaning that the right hand side is non-zero. Okay, non-zero. So you will learn these two methods of undetermined coefficients and also the method of variation of parameters. Okay, so these two methods, one will be covered under midterm, another one covered under final exam. Okay, now we look at how to solve this kind of differential equation. Now let's say you have this differential equation. This is a second order linear and non-homogeneous differential equation with constant coefficient. Constant means A, B, C are all constants. Okay, constants. And this is non-zero. So to get the final solution, you have to find for two solutions. Okay, YC and YP. Okay, after you get the YC and YP, then you combine YC to the YP, you will get the final solution. Okay, what is this YC? C stands for complementary. Okay, complementary. So this YC is actually what we have learned in the last class. Meaning that we will let fx equals to 0. Okay, we let fx equals to 0, then you have this. Okay, so from here you get the characteristic equation, find for the values of m and form the YC, okay, form the solution based on the three different cases, the real and distinct, real and the same, and also the complex conjugate. Okay, so that solution that you obtain is now known as YC. Okay, YC. So this one you have learned, but the solution now we name it as YC. Okay, next we have to find for another one particular solution. Okay, particular solution. So particular solution based on this fx. Okay, based on this fx function. Now we start with the first method. Okay, today we will look at this method. Okay, so method of undetermined coefficients is applicable only when your right-hand side function fx is a linear combination of products of function of these three types. Okay, meaning that if your fx is a polynomial or exponential function or cos or sine function. Okay, but if you look at this exponential function, it accepts only this kind of exponential function, meaning that x to the power of 1. If you have ex squared, that is not applicable. That means we can't get to solve using this method if you have x squared. So for exponential function, it is only allowed for ERX, x power of 1. Okay, and the cos and sine function also the same. X power of 1. Okay, x power of 1 and cos also power of 1. Okay, sine power of 1. So this kind of function, okay, product means you can have polynomial multiplied to exponential or exponential multiplied to cos or sine, or polynomial multiplied to exponential and also cos and sine. Okay, this is product. This is called product. Linear combination of product means I can have the fx to be polynomial multiplied to exponential plus polynomial multiplied to sine. Okay, this is linear combination. Okay, so this kind of functions, okay, is applicable for this method. Okay, linear combination of products of these three types. Okay, so in short, we can have these few types. Okay, polynomial only, exponential only, cos only, or sine only, or linear combination of cos and sine, or polynomial multiplied to exponential, or polynomial multiplied to either one of this, or exponential multiplying to either one of this, or we can have these three product function of these three, or we can have any of one of this category plus another category. Okay, this is considered as one category. Yeah? So 1, 2, 3, 4, 5, 6, 7. You have 7 categories. So we can have, for example, we have this one category plus this one category. Okay, so we have 2 categories in that fx. Okay, we can have that. Now back to this. The fx can be any function as shortlisted in the table 2.2. This is table 2.2. Okay, table 2.2. This is your fx. Choose the smallest non-negative integer for s. Okay, what is this s? Okay, here. You see all of this function, you have an x to the power of s. Okay, x to the power of s. So we need to choose the s, okay, but s is the smallest non-negative integer. What is the smallest non-negative integer? 0 or 1? 0. 0 is the smallest non-negative integer because 0 is not negative and 0 is also not positive. So the non-negative, okay, non-negative means it will start from 0. Okay. 0 is not negative. So the smallest one is s equals to 0. Okay, it must be integer. Okay, so how to choose the s? Okay, we choose the s in such a way that yp does not duplicate with yc. Okay, yp does not duplicate with yc. Okay, this one I will show you through the examples later. So what you need to know now is, according to the fx, you need to come up with your yp. Okay, but before you get the yp, we will start from the y trial. Okay, y trial, because we need to determine what is the value of s. Once you have confirmed the value of s, then you get your yp. Okay, so what is this? What is this column means? Okay, now we look at this one. The first category is the polynomial. Okay, polynomial. So your y trial, okay, I will use the term of y trial. The y trial will be this one. Okay, this one, starting from a0 up to an xn. Okay, meaning that this is just a general form of the polynomial function. Okay, I think this one I would prefer to write on board. I give you some examples. Then you know what it means by the general form. Okay, let's say your fx is x squared plus 1. Okay, then your y trial, we will start with the y trial. Y trial is the general form of the function. So this is a polynomial. Okay, this is a polynomial with degree of 2. Okay, with degree of 2. So the general form, it will be ax squared plus bx plus c. This is the general form. Okay, so your fx, no matter what is your fx, this one. Let's say I give you another one, 1 minus 2x squared. The y trial is also this one. Because the order is, not order, the degree is 2. Okay, this one also this. If your fx, let's say, is negative 3x to the power of 3, then your y trial will be ax cubed plus bx squared plus cx plus d, the general form. And we look at the degree. Okay, the degree, starting from the degree. Okay, so no matter what is the values here, no matter positive or negative, this one you will always have positive constant. Because when a is negative 3, b0, c0, d0, you get this. For this one, for example, this one, a is 1, B is 0, C is 1, then you get this. This is the general form for category of polynomial. If you have exponential function, let's say 2e negative x, then your y trial. Okay. So A, no matter if this is any constant, okay, any constant, you will have A e negative x. This one. Okay. Let's say another example, negative e x. So your y trial, it will be, what is your y trial? The general form of this case, A e x. Yes, A e x, the general form. Okay. Next one, sine and also cos. Let's say 2 sine 3x. Okay, your y trial. Okay, this is power of 1, power of 1. Okay, accepted. So this one we have, okay, it comes in a pair. For sine or cos function, it comes in a pair as cos and also sine. Okay, so even if your or if your fx is 3 cos 3x, the y trial is also this one, 3x, and it comes in a pair, cos and sine. So that's why when you look at the table 2.2, okay, that's why when you look at this one, this case, your general form is this. And for exponential function, your general form is A e Rx. Okay. And either cos or sine or the linear combination of cos and sine with the same angle, it must be the same angle. Then you have this. Okay, these three cases. Okay, I will start with these three basic case first. Okay, so if you have the product function, okay, product function, this one polynomial with exponential, means that you will come up with the general form of the polynomial function, which is this one, and then just multiply the exponential function. Okay, just multiply an extra e. If you know how to read this table, I think you know how to come up with the rest of the y trial. Okay, for example, this one. This one. Let's say this multiply to the ex. Okay, this function multiply to ex. So your y trial will be the general form of the function polynomial multiplied to the ex. Okay, just an extra of ex. So if you have polynomial with cos or sine, okay, polynomial with cos or sine, for example, this one, polynomial, let's say 2x times sine. Okay, let's say 2x times sine. 2x is the polynomial multiplied to the sine function. So the y trial, it will be the general form of 2x is general form of 2x ax plus b, ax plus b, x power of 1. You look at the order, the degree. Okay, the degree of the polynomial. X power of 1, you could have this one starting from this, and then the rest of the Bx or C, it must follow. Okay, it must follow because when A is 2, B is 0, then you get this. Okay, even though you didn't see +1 or -1 or plus any value here. Okay, you still have to write this out. Okay, this one you have. Okay, normally we start with cos. Okay, cos, and then we still have another one for sine, right? Okay, so here also the general form of this, but with different constant, meaning that Cx plus D. If you look at the table, okay, if you look at the table, this case, okay, in this case, so you will have the general form of the polynomial times cos plus the general form of the polynomial with different constant. You see here, these are all A. Here, these are all B. So that means different constant. If you use AB here, that means here will be CB. Okay, and then sine. Okay. So the one with exponential function is quite straightforward because we just need to multiply the exponential function. Okay, I will move to how to solve. Okay, how to solve using undetermined coefficients method. Okay, first you are given the AY double prime plus BY prime plus CY equals to a non-zero function. Then we will start to get the YC first. Okay, so you let the right-hand side function to be 0. Okay, you let the right-hand side function to be 0. Then find for the characteristic equation. One, then factorize, get your M1, M2. Okay, then obtain your YC according to the case. Okay, which case you get from here. Okay, the 3 different cases. Okay, and after that, look at the fx. Okay, look at the fx. Then you form your y trial. Okay, form your y trial. Then we will choose the s. Okay, we will do the checking. We want to see whether this y trial has duplication with yc or not. Okay, if no duplication, then you get a yp. If there is duplication, we will insert an extra x. Okay, sorry, extra x, not x, extra x. Okay, this one I will show later. Okay, once you have get the YP, okay, but your YP with constant with the ABC. So we will differentiate the YP twice, and then we substitute the YP, YP prime, YP double prime into the question, okay, into the differential equation. Then we will compare the coefficients on the both sides to get the values of the ABC. Okay, and finally, we will combine the YC and YP to get the final solution. Okay, this table is not given in any of the assessment, just like the table 2.1, the 3 different cases. And also this table is not given. So we have to know how to come up with the general form. Okay, general form. Okay, now we look at this. Okay, we try this exercise. These are the simple one. Okay, these are the simple one. Find the general solution of this differential equation. Okay, so first we will let the right hand side to be 0. So meaning that we will solve for this. Okay, so get the characteristic equation. Then find for your m. Then get your YC. So the characteristic equation is n squared minus 3n plus 2. Okay, what are your m? What are your m values? 2 and 1. Okay, 2 and 1. So this is real and distinct. Case 1. Okay, case 1. And what it has now is YC. YC. So C1 E2x plus C2 EX. Okay, this is what you have learned in the last class. Okay, next, your fx is 4x. Okay, your fx is 4x. So what is your y trial? Ax plus b. Ax plus b. Okay, now we want to check for the duplication. Okay, the duplication, it means from YC, this is your Y1, this is your Y2. Okay, from YC, this is your Y1 and Y2. And from Y trial, you have X and constant only. Okay, X and constant only. So do you see any duplication? Duplication means if you have, let's say BEX, let's say BEX, that means this duplicate. This duplicates because B is a constant, C2 is another constant. That's why we use the term duplicate. Okay, duplicate, that means they are the same exactly function. So do you see any duplication? No, no duplication. So this is your YP. AX plus B is your YP. So what's happened if there is a duplication? If there is a duplication, meaning that we will put this into a bracket and then insert an X in front. Something like this, X and then AX plus B. Let's say there is a duplication found. Then we will insert an extra X in front of the Y triangle. Okay, because we will check for this. Okay, this one, after you expand, you have AX squared plus BX, right? Then we will check again. Is there any duplication from this y trial compared to the yc? If no, then that is your yp. If yes, we multiply one more x, then you have x squared in x. We will multiply the x until there is no duplication between the y trial and also the yc. Okay, once you have get your yp, and your yp is ax plus b. So we will differentiate twice because our differential equation is second order, so we will differentiate twice. Okay. So yp prime is a, yp double prime is 0. This is constant. Okay, then this is your differential equation. Okay, this is your differential equation. So now you substitute y double prime 0 minus 3, y prime is a plus 2, y is a x plus b. Substitute the y double prime, and y into here. Then, okay, what do you have now? Negative 3a plus 2ax plus 2b on the left. And now we will compare the coefficient function of x power of 1. Okay, x power of 1. So what do you have on the left for x power of 1? We look at the coefficient function. The one with x, there's only one term, right? There's only one term that contains the x. Then the coefficient function is 2a plus 2a, coefficient function plus 2a. And on the right hand side, what do you have? 4, right? 4. Then your a is 2. The next one we have to find for b. Your b is here. And this is a constant only. Okay, so we compare the constant. X power of 0 means that this is a constant. Okay, constant only. So constant only. What do you have on the left? What do you have on the left for constant only? Negative 3a plus 2b. And how about the right hand side? 0. Okay, so now with the value of a that is found, you can get your b. Okay. Continue here. So your 2b is 3a. 3a. So your b is 3. Okay. So now you have found your yp. You have found your yp. Your yp is a x plus b. Okay, now once you have get your yp, okay, yp the one with values, then you can get your final solution. So your final solution is yc plus yp. Yc plus yp. So I repeat one more time for this undetermined functions method. Okay, this is a polynomial, so we can use undetermined coefficients method to solve. First, we will let the right-hand side to be 0. Okay, find for the characteristic equation, factorize to get the values of n, form your YC based on the 3 different cases. Okay, different cases for the n values. Next, we look at the fx function. We form the general form. We find the general form, and the name is y trial. Y trial. For x, y trial is ax plus b, the general form. Then we check, is there any duplication between y trial and yc? Okay, yc, so we look at the function, the y1 and y2. Okay, y1 and y2. So your y trial, you have x and constant only. Okay, x and constant only. But here you have exponential function, though, so they are not the same. No duplication. If no duplication, your y trial will be your yp. Okay. Once you have get your yp with constants, okay, with the unknown, we differentiate twice. Then we put them into the differential equation. Then you get this. Okay, then we will compare the both sides of the coefficient functions to get the values of these two. Okay, once you get it, update your YP, form the final solution by combining the YC and YP. Any questions? Midterm, any questions? Okay, no question. We look at the second 1B. Well, it's fine for your tenants.
This
is not x prime. This is x power of 1. X power of 1 for this one. X power of 1. Because we want to get the values of this AB, right? So this A with x. That's why we will take the coefficient function of x power of 1. Okay, now get a YC first. Get a YC. Attendance, 12. Okay, so we let the right-hand side to be 0. Come up with your characteristic equation. Okay, remember this. When there's no y prime, that means no m. Okay, so what is your m values? 2 and -2. So your YC, this is the case 1. Okay, case 1. So your YC will be C1E 2x plus C2E -2x. Okay, now your fx is 2e2x. So what is your y trial? Okay, so what is your y trial? AE 2x. So now we check for duplication. Is there any duplication found? Yes, there's a duplication here. So what we do? Okay, we insert an x. Okay, we insert an extra x. Then we check again. We check again. Any more duplication? Okay. So no more duplication, meaning that this is your yp. Next, we differentiate yp twice. Okay, differentiate yp twice. So yp is ax e to x. Get your yp prime and yp double prime. Okay, this one you have to use the product rule. Okay, product rule. Then differentiate once again. This one you get a 2a 2x plus. Okay, this one, let's say you differentiate x. And then you copy x, differentiate this. When you differentiate this, you have an extra 2. So 2, you get 4a x e 2x. These two combined. Okay, next, substitute this 3 into the differential equation. The y double prime is 4a e2x plus 4a x e2x minus 4 y a x e2x equals to 2 e2x. So we can cancel out this 2. And we have only this 4a e2x equals to 2 e2x. Okay, so now we compare the coefficient functions of the both sides for e2x. So on the left, we have 4a. And on the right, we have 2. 4a and 2. So that means your a is half. Okay, then update your yp, combine to the yc, then you get your final solution. So yp is half x e2x. And finally, y is yc plus yp. Okay, your yc is c1 e2x plus c2 e negative 2x, then plus half x e2x. Any questions? Any questions? You have to remember the floor. If no questions, we proceed to number 2. Okay, fine for the YC. Tapi kalau saya buat space bar, itu juga ada tak aplikasi space bar itu kan kalau ada yang boleh datang kita coba tapi kalau now let the right hand side be 0. So your characteristic equation gives, what is your m? Plus minus 2i, right? Plus minus 2i. This is a complex conjugate. So case 3. Case 3, so your YC will be alpha is 0. Alpha is 0, so E0 is 1. Then followed by C1 cos beta x plus C2 sine beta x. Okay, up to here. Any questions? Okay, remember the formula for this YC is E alpha X, and then in the bracket you have C1 cos beta X plus C2 sin beta X. But your alpha is 0. Okay, P0 is 1. That's why you do not have any exponential function here because of 0. Alpha is 0. Okay, next, your fx is y sine 3x. What is your y trial? What is the general form of this function? It comes in a pair. A. It will always start with a constant A. Cos 3x plus b sine 3x. Okay, now check for the duplication. Is there any duplication? No duplication because their angle are not the same. This is 2x, this is 3x. So not the same. So no duplication. If there is no duplication, it means that this is your YP. Okay, then next, differentiate points. YP prime and YP double prime.
Từ ba phần ba là từ nó là từ đây là bài toán là từ
So A cos you get a negative sign. So negative 3A sine 3x plus 3B cos 3x. Differentiate one more time. Negative 9A cos 3x minus 9B sine 3x. Then substitute this YP prime, YP double prime into your differential equation. Okay, Y double prime and Y. So Y double prime plus 4 Y. Okay, equals to 5 sine 3x. So simplify, negative 9a plus 4a, negative 5a, and negative 5b. Okay, then we compare the both sides for function of 3x, cos 3x. Okay, cos 3x on the left, we have negative 5a. Negative 5a. And on the right hand side, we do not have cos. So it's 0. So a is 0. And next, we compare for sine 3x. Sine 3x, we have negative 5b. And on the right hand side, for sine 3x, we have 5. So that's why b is negative 1. B is negative 1. Then update your yp. Combine with yc. Yp, a is 0, b is negative 1, so negative sine 3x. Questions? Any questions? Three A, the question is the same as number 2. The equation, okay, the differential equation is the same as equation from number 2, but it gives extra the initial value. With the same differential equation, it gives extra initial values. So we continue from here. Okay, because when you are solving for this, okay, that's what you have done just now until you get this general solution. So what is the use of this initial values? To find the values of C1 and C2. Okay, so now we will start from here. Y0 equals to 1. Okay, Y0 equals to 1. Meaning that when X is 0, Y is 1. Substitute here. When X is 0, y is 1. Because we are using the same differential equation, so we don't have to repeat all this. We just take the solution from here, from number 2. Okay, and then we substitute the initial values. Okay, when x is 0, y is 1. The y is 1. So you have C1 cos 0 plus C2 sine 0 minus sine 0. Okay, cos 0 is 1. Sine 0 is 0. So meaning that C1 is 1. Okay, C1 is 1. Then before you apply for second initial value, you have to get the y prime first from here. Okay, differentiate y, differentiate your general solution to get the y prime. The differentiate cos, we get negative sign. So negative 2c1 sine 2x plus 2c2 cos 2x. Then minus 3 cos 3x. Then only you substitute the second initial value. When x is 0, y prime is 1. Y prime is 1. Sine 0, 2c2 cos 0 minus 3 cos 0. So sine 0 is 0, cos 0 is 1. So you have 2c2 minus 3. So your 2c2 is 4, c2 is 2. Then update your final solution. Y is the 1 is 1 cos 2x. C2 is 2 plus 2 sine 2x minus sine 3x. Okay, any questions? Okay, now we look at the last one. The last question. 3B. Okay, so that the right hand side is 0. Form the characteristic equation when there is no y prime, no f. Okay, then you can get your YC. This is real and distinct, case 1. Okay, case 1. Okay, now this question, the fx is a linear combination of 2 different categories. A linear combination of 2 different categories. One is polynomial, and then plus, another one is exponential functions. Okay. On your y trial, okay, 3x, what is the general form? Ax plus b. And then the general form for exponential function is supposed to be a e2x, but since a already taken, so c e2x. Okay, then check for the duplication. Is there any duplication? There's a duplication on e2x, right? But this duplication happens to the second category. So no duplication to the first category. So it remains the same for the first category. But we insert an x for the second category. Okay, because the question 1A, 1B, number 2, and 3A, they are all just involved only one category. But this 3B, it has 2 categories. So we will check where is the duplications happen. Okay, it takes place only at the second category. Okay? It happens only to the second category. So we just insert the x to the second category. Okay, no changes on the first category. Okay. Check again, is there any duplication? No, no more duplication. Then this is your YP. Okay, once you get a YP, differentiate twice. Okay, differentiate twice. And this one you can combine. Okay, then substitute the YP prime, YP double prime into the differential equation. y ax plus b plus dx into x. Okay. We can cancel out this one and this one. Okay. To get the values of A, B, C, you need to compare the coefficient function of e2x. A, you need to find from A, A you need to find from x, B you need to find from constant. So for e2x on the left, we have 4c. Okay, we have 4c on the left. E2x on the right, we have plus 1. Okay, for x on the left, we have negative 4a. And on the right, we have 3. And for constant only, on the left, we have negative 4b. And on the right, we do not have constant. Okay, we do not have constant only, so 0. Okay, then now you have get the values of A, B, C. So update your YP. AX plus B plus CX E2X. For this question, the initial values is given. Initial values 0 is 0, y0 is 0, and y prime 0, 1. Okay, this is given in the question. So your general solution is YC plus YE, which is this one, C1 E2X plus C2 E negative 2X plus the YP. Plus the YP minus 3 over 4X plus 1 over 4X E2X. Okay, so this is your Y. Then we substitute the initial value. Y0 is 0. When x is 0, y is 0. Okay, so y is 0 when x is 0. So C1 E0 plus C2 E0. This one is 0, this one is 0. We have only this. E0 is 1. So you get the first equation. Okay, the first equation, C1 plus C2 is 0. Then y prime. Before you apply the second initial value, you have to find for your y prime. C1 E2X minus 2 C2 E negative 2X minus 3 over 4 plus 1 over 4 E2X plus 1 over 2 X E2X. Okay, then only you substitute the second initial value. When x is 0, y prime is 1. Now here, when y prime is 1, x is 0, so 2c1. 2c1 minus 2c2 minus 3 over 4 plus 1 over 4. Okay. Okay, simplify. 1 minus 4, 1 over 4 minus 3 over 4, you get a negative 2 over 4. That's mean negative half. Okay, negative half. When we move to the left, it will be plus half, 1 plus half, 3 over 2. 2c1 minus 2c2. Okay, then from the first equation here, we can write c1 as negative c2. Okay, c1 as negative c2. Here, c1 is negative c2. Negative 2 minus 2, negative 4. Negative 3 over 8. C2 is negative 3 over 8. So your C1 is negative 3 over 8 is C2. C2 is negative 3 over 8. So negative, negative, you get a positive 3 over 8. Okay, then substitute the C1 and C2 into your y to get the final solution. Y is 3 over 8 e2x minus 3 over 8 e magnitude x minus 3 over 4x plus 1 over 4x e2x. Okay, any questions? Okay, give me 5 minutes. I want to give some more examples for different case of FX. Can I run this out? Yeah, just give some more examples, okay, for you to find for the Y trial. Now look at this. Let's say this is your YC and this is your FX. What is your Y trial? AX plus B for this one. Okay, and then E2X. Okay, this is your Y trial. Is there any duplication? Yeah. Which one? Yeah, this one will E. This one will E. So this means you have AX E2X plus B E2X, right? This means you have these two. Okay, you have these two. So there is a duplication here, right? E2X and also this one. This is considered as one category, because this is product function. So we insert an X. Check again, is there any duplication? There any duplication? Yes. When you open the bracket, the function that you have is X square E, right? X square E and also XE. Now check with that too. You have one duplication here, right? So meaning that we insert one more. Okay, any more duplication? Okay, no, this is your YP. Okay. Okay. Let's say this is your YC. This is your FX. What is the Y trial? Cost function comes in a pair. A cos X B sin X. Is there any duplication? Yes. What do you have here? EX cos X, EX sin X, right? Open the bracket. The function that you have is EX cos X and EX sin X. So no duplication. No duplication. Because when we do the comparison, you have to take the whole function. This one because you have bracket. So this one, when you open this bracket, EX multiplies into here and here. The function that you have are actually EX cos X and EX sin X, not cos X and sin X only. Okay, you have to open the bracket, just like this case. When you see the bracket, you have to open the bracket to check what are the functions that you have. Okay, so this is your YP. Okay, so this is the product function of polynomial and sine functions. So what is the Y triangle? General form of 1 minus x squared is A x squared plus bx plus c. Okay, for sine, it comes in a pair, right? It comes in a pair, cos and sine. Normally, we start with the cos first, okay, and then plus sine, right? But here, remember the formula from the table 2.2 just now? All are A, here all are B. Meaning that if you use A, B, C, here will be D, E, F. Okay, this is for the case of the product function between polynomial and sine. Polynomial and cos also the same. Okay, polynomial with sine or polynomial with cos. So the polynomial, you have to change the constant. Okay, this one. What's your Y triangle for 3x? 3x, Y triangle is AX plus B. Is there any duplication?
Yes.
X. And also this one, constant also, duplicate with constant. So you need to insert X here. Okay. Any more duplication?
Yes.
Yes. Here, BX with the X. So X squared, AX, X plus B.
Yeah.
Okay. Polynomial with exponential. Okay, one more. The product function of 3. Okay, 3 polynomial, exponential, and sine. So what is the Y triangle? This one is actually similar to this. It's just that there's an extra EX. When you have an extra EX, that is simple. You just insert EX here. So you have AX plus B, EX. Okay, we start with cos X, and then plus AB, then CX plus B, EX, sine X. Okay. Any duplication? Any duplication?
Yes.
Which one? When you open the bracket, you have x, ex cos x, and then ex cos x, ex sin x, and ex sin x. Here you have ex cos x, ex sin x. So the ex cos x and ex sin x duplicates with the one with here, right? So when you insert an x, meaning that x multiplied to the whole function, because this is considered as one category. Yeah? This is considered as one category. What it means by two category? Two category means x ex plus, let's say, 2 cos x. This is considered two categories because this is polynomial with exponential. This is cos only. This is two categories. So when you do the checking on the duplication, if the duplication happens only here, that means only this part, the second category, multiplied x in the y trial. Okay. Okay. Any more questions? No, then we end the class here. And in the next class, we will move into the second method, variation of parameters.